follow some things you guys did. So the first thing we did was we moved the c over because we didn't think that that was necessarily the right constant because we don't know what value c has. Oops. And then we divided everything by a. Is everybody okay with how this looks right now? Morgan? You can, but you'll eventually have to divide by a anyways because we're solving and not just rewriting. Okay? All right. So it's now set up where I can add in the constant that I want. Is everybody okay with why I get that we don't enjoy this because we have all these variables going on, but does everybody get that I feel like I can now go through the completing the square process? Like I moved over the constant that didn't match and I got rid of the coefficient in front of x squared. Is that okay with everyone? So I'm trying to kind of fill in this spot. And so what was our procedure for doing that? Good. Okay, so we take b, we divide it by 2 and square it, and b is the middle term. So currently our middle term is this. Okay. So if we take that, we divide it by 2, and again, kind of did this yesterday. Are you okay with my dividing by 2 looking like a multiplying by 1/2 because it's already a fraction? And then I'm going to square it. So that would be b over 2a being squared, which would be b squared over 4a squared. Is everybody okay with how I'm making my choice? Because it's looking really random here because we don't have numbers to connect it to. But is everybody okay that I'm just going through the same procedure that we went through yesterday? Okay. So I'm going to add this quantity, even though it looks maybe disturbing for some people. So I'm going to add b squared plus 4a squared. And when I add that new quantity to the left side, I also need to add it to the right side. Is this okay with everybody? All right, and then what is our purpose? Every time we complete the square, our next step should be? We want to use a radical because we're solving. So what should our next step be after completing the square? Good. Okay, Noelle's got it down. We completed the square in order to make a perfect square. So the next thing we should be doing is writing this as a perfect square. What would be the first term in our factored perfect square here? X. And what is going to be the second term? B over 2a. And people that are wondering how we got that because we're trying to think of what times itself made this b squared over 4a squared. Okay. And then should it be plus or minus? Plus, because it's got to make middle terms that are positive. So those two middle terms, when I FOIL or distribute it out, need to combine together to be positive. Therefore, they must both be positive. So I want a positive. Okay. And on the right side, I just want to combine everything into one fraction so it's not separated. So I'm going to make a common denominator. And basically, that means I need to multiply the denominator of this fraction by 4a. So it'll look like 4a squared just like the other fraction does. Right? Looking great, right? It actually does. It's so amazing. Okay, so next step. What do we do when we get here and we're trying to solve? Okay. Good, with a radical. We're trying to solve for x. X is all completed inside this little square so that we can square root it and get rid of the squared thing, right? So I'm going to go ahead and square root the left side and square root the right side. When I square root both sides of the equation, what do I have to remember? Plus or minus, right? If I'm thinking of a number squared and it comes out to be 4, the answer is not necessarily 2. It could also be negative 2. So on the left side, I'm going to have x plus b over 2a. On the right side, I'm going to have plus or minus. Now this radical is over the entire fraction. In the denominator, this actually square roots very nicely. The square root of 4a squared is 2a. And the numerator is just ugly. I'm going to rearrange the order of things in there, okay? I'm going to keep negative 4ac and I'm going to keep b squared, but I'm going to write them in a different order because you'll understand in a minute. Oh my gosh, right? So what is the last step I have to do to get x alone? Good, I need to subtract this b over 2a so that x is by itself from both sides, and then this ends up looking like or in other words, what we're more used to seeing. All right, so all you guys who memorized the quadratic formula in the past and are like, okay, some mathematician made up some little order of what he wants to calculate, the A's, B's, and C's to figure out this number, now know that really this formula is more a development of people probably got sick of completing the square, right? Those of you that started the homework, did you get sick of completing the square? No. Okay, no. Noelle likes completing the square, just so you guys know. I'm with her, but not everybody falls into that same category. If you're doing that over and over again, you could see how it would get frustrating, right? When we had those coefficients and stuff like this. But if you're doing the same pattern of steps every time, you can take something like this, generic form of something, and do the steps with that and come up with a formula that says, hey, in the end, here's what you're doing to all these things in one formula. So if you memorize this formula, you don't have to go through the steps of completing the square every single time. So really, the quadratic formula and completing the square are the same thing. This is why they both solve quadratics, okay? The completing the square is the process. The quadratic formula is the process summarized because people get sick of doing the process, okay? Does that make sense to everybody? All right, so did people make up this random stuff? No, it actually came from just doing the math operations, and then they just said like, hey, can't we just make a formula that does this? Yes, we can, because we do these same steps every single time, okay? If you forgot your quadratic formula, make a little note for yourself to like memorize it, all right? Because clearly it's going to be important, especially if you don't want to complete the square all the time. But if you did get stuck and forgot the quadratic formula, you can always just complete the square, okay? That's where it came from. You could do it. All right. Are you guys pretty impressed? Like, that's pretty mathematically amazing, right? It's a pretty cool thing. Okay. All right. Not a lot of things come together like that, but in Algebra 2, you get a few things that I think, maybe not for all of you, but in Algebra 1, I just memorized stuff and did stuff and like copied procedures. And then in Algebra 2, I was like, oh, like it actually like makes sense where it came from, what I'm doing, okay? All right, so go ahead and we're going to just look at example 1. And so just real quickly, make sure you guys can actually solve something using the quadratic formula. Take this equation and solve it using the quadratic formula, okay? And just to make sure everyone's on the right page, in order to use the quadratic formula, what has to be changed about the setup that's here? Yeah, it has to be set equal to 0. Okay, so don't start without that. You'll have the wrong sign for one of your A's, B's, or C's if you don't set it equal to 0. But then you should be able to go from there. So go ahead, work on... All right, I think I plugged in right, so you guys can check if you got answers at the end. So a couple of things. Number one, under your radical, did you get 44 to make sure that calculation is correct? And then 44 breaks down to 4 times 11, and 4 is a perfect square. So I rewrote the square root of 44 as 2 rad 11. And so I had 2 plus or minus 2 rad 11 all over 10. And all of those things are divisible by 2. You guys need to be really careful that you're not like just dividing this 2 by 10 and just simplifying those parts. Remember, that 10 is a denominator for both of those terms. So if you're going to simplify it, you either have to separate it if only one part simplifies, or make sure you're taking the same factor out of each term in the numerator and then also in the denominator. Okay. Any questions about this? Okay, what does this mean about the parabola? If I went to graph this parabola, okay, I would graph 5x squared minus 2x minus 2. Which direction do I expect that parabola to face? Upward, okay, and how do I know? Where am I looking when I look at that? The a value is positive, okay? And do I expect it to cross the x-axis? Okay, what did we just do? We solved. Solving finds solutions. What other words in the world of quadratics are synonymous with solutions? They could also be called x-intercepts or roots or zeros. So if we have solutions, do we cross the x-axis? Yes. Yes. Are they at nice, really easy to graph points that I can clearly see on my graph, so easy to tell? No. 1 plus rad 11 divided by 5 and 1 minus rad 11 divided by 5. Maybe not a pretty number, but crosses the x-axis twice. Is that okay with everybody? Okay. So I want to talk about the discriminant. So the discriminant is a specific part of the quadratic formula, and it is the part that would determine how nice your answers are. So we just looked at the answer we got here, 1 plus or minus rad 11 over 5, and we decided this parabola does cross the x-axis. It crosses at 2 places, and if I had to describe the numbers where it crosses, are they real numbers? Yes, our whole number line is real numbers. So if it's hitting the x-axis, you have 2 real solutions. Is a number like that a rational number? No, because rad 11 is a never-ending, non-repeating decimal. Okay, all of our square roots that don't simplify are like that. So it's irrational. So not only do I know this crosses the x-axis, but I could describe the types of numbers that it crosses at. It crosses at 2 of them. They're real because they're on the x-axis, but they're irrational because they're these like crazy decimal numbers. Is that okay with everybody? What would have made it work out so that they weren't crazy decimal numbers? If we were doing a calculation like this in the quadratic formula, which part of the quadratic formula would have had to change if we wanted it to work out really nice to like a nice whole number or a basic fraction without a repeating decimal? Which part of this answer would have to be different? What's that? Good, the radical would have to be different. If instead of rad 11, I had like rad 16, would that have worked out differently? Yeah, because what's rad 16? 4. And then could I have done 1 plus 4 over 5? I might have still got a fraction, but a fraction is a rational number, not an irrational number. So if I want rational numbers, I want the number underneath the radical to be a nice perfect square. If it's not a perfect square, then I'm getting irrational numbers. What would happen underneath the radical to be able to look at it and be like, it doesn't cross the x-axis? So some of you at first said no, and then we were like, no, it does. It crosses twice. Emily? If there was no solution. And in this calculation, what would cause us to get no solution? Vanessa? A negative underneath the radical, okay? And then sometimes so we've determined a parabola can hit the x-axis no times. It can hit 2 times, either at rational or irrational numbers, depending on how complicated the radical is. Could it hit 1 time? Could a parabola hit the x-axis just 1 time? Can you picture in your head a way that that could happen? How could it happen? Someone new. I see people smiling. Yeah, Taylor. Okay, so one is if it's turned sideways. We don't study those kind of parabolas in here, okay, but totally good answer. So we don't study those kind in here because we only study ones that are functions. So we only study ones that pass the vertical line test, but you are totally correct. Josh, if the vertex hits the x-axis, are you guys okay with that? If it is concave up or concave down, but it just comes, the vertex right on the x-axis and it turns around. And that would mean you only get 1 answer. What would have to be true about our calculation here in the quadratic formula for it to only get 1 answer instead of 2? Zoya? There can't be a plus or minus, which means what would have to have happened here for me to not include the plus or minus in my calculation? Stefan? What's that?
A 0.
Good. A 0 specifically where? In the radical. Do you guys notice that the whole conversation we just had about when would this happen, when would this happen, everything that had to change the kind of answers we got had to happen in the radical. Fair enough? So that calculation that's in the radical is actually really important. So it gets this special name. It's called the discriminant. And the discriminant is this calculation. Because the calculation underneath the radical is not determining necessarily like what the answers are, but knowing that one number can tell me the types of answers I have. Like, will it hit twice? Will it hit once? Will it hit twice at good numbers or bad numbers, will it not hit at all? Is that okay with everybody, that we can tell that just based on that number? All right, so we're going to split up the work here. So we basically just want to do this. So I'll do the first one, and then we'll split up the work for the second one. So if I was doing this one, the discriminant, remember, is specifically this calculation. No radical on top of it. I'm just thinking, what would the number be underneath the radical? If I did that with this first equation, I'd have 7 squared minus 4 times negative 2 times 10, which would be 49 plus 80, which would be 129. Okay, so 129, if I were to graph this, which way does this parabola face? Down, because the one is negative. And I'm just sketching, so I'm not even putting it in the right place. If the number underneath the radical is 129, does it cross the x-axis? Yes. How many times? Twice, because you have a number in the radical, so you're going to have to add and subtract. Do the numbers turn out to be really nice or not so nice? Not so nice. The square root of 129 is not super friendly. So I know that I'm getting 2 real but irrational solutions. Oh, sorry, I filled this box in. So the number of solutions is 2. The type of solutions is that they're real. They actually cross the axis, but they're irrational. Okay, they're not nice numbers that are going to work out really easy to compute because my radical is a little bit messed up. Okay, the sketch of this graph, all I'm asking you guys to do here, it's a really, really, really rough sketch, is to draw it facing the right way and crossing the axis the right amount of times. So, okay, I just want you to understand, like, I know which way it's going. I know it crosses the axis twice. I didn't do any arithmetic to actually figure out any points here. I'm just understanding basic structure. Okay. All right, so we're going to split it up like this. These 3 groups over here, groups 1, 2, and 3, you guys are going to do this next equation. Okay. The groups in the middle, groups 4, 5, and 6, you guys are going to do the second to last equation right here. And then over here, groups 7, 8, and 9, you guys are going to do the last equation. When you guys have information, meaning you did it, you checked it with someone, call me over. I'm going to fill it in on here, and then we're going to share it off here. All right, any questions about this? So do you understand what the discriminant is when you see the word discriminant? Do you understand? When would you use the discriminant if they don't say discriminant in the question? You would use it if the question is about how many solutions or what kind of solutions. If it's what are the solutions, you need to go solve it, right? Completing the square, quadratic formula, factoring. But if it's like what kind of solutions, do you actually have to solve it? No. So you could do a smaller calculation and quickly figure out the kind of solutions if it's just trying to understand the basic structure of the parabola. Okay? So everybody should understand what the discriminant is and the types of solutions it gives you. Okay. So I'm going to ask you guys, we're going to do one more. So I want to ask you guys where you need the most instruction, okay? So if I look at example 3, it says, what is the number of real solutions? Does it even ask you to solve for the solutions? No. So if it asks you the number of real solutions, what calculation do you want to do? Discriminant. Do you guys need help doing a discriminant calculation, or do you feel like you understand how to do that? You understand how to do it? So you like move over the 49 would be the only tricky thing here. Like make sure it's set equal to 0 before you start. Otherwise you won't be using the right signs of things, okay? Would you guys rather look at this word problem with this equation? Okay, let's do that. All right, so it says a rocket is launched from the ground with initial vertical velocity of 100 feet per second. So that's like a lot of like information, physics information. But the next part is the lifesaver. Like I don't even care. I mean, I care, but I don't care because the next thing it says is the function, this thing, models the height in feet at time t in seconds. So I don't really have to know that it's going at 150 feet per second unless I was like working on the physics part of it. They already made the equation for me using the physics part of it. So I'm really just going to rely on this equation. And for those of you that struggled in Skill 4 homework, the beginning front page of it, every time I talk to someone, I'm not saying this is everyone's issue, but it was really just about understanding what was in the problem, right? So normally we have y and x. In this problem, we don't have y and x. We have h and t, right? But t is kind of like our x. And what does t stand for in this problem? Time in seconds. And h is like our y. And what does h stand for in this problem? Height, okay? So if I had to understand what's happening in my head, just a little glimpse, the shape of what this rocket's whatever information looks like on the graph is a quadratic, so it will be shaped like a parabola. The lead coefficient is negative, so the parabola will go downward, okay? And they actually gave you some really nice here. They said it was launched from the ground, which means at time 0, you actually know it's on the ground. If you didn't know it was on the ground, maybe it is, maybe it isn't, how could you figure out whether it's hitting at the origin or not? How would you find out if this is a point on your parabola or not? What's that? So this isn't the vertex, but if you want to know where the parabola hits on the y-axis, what do you need to do? Plug in 0 for x, right? So if you're a little worried about drawing the picture accurately, as if like, does it go like this versus in this case it doesn't, okay? It goes like this, then you could get a y-intercept. Because if your y-intercept's negative, sketch it so that it starts down in the negative, right? If your y-intercept's positive, sketch it above. If your y-intercept's 0, then you sketch something like this. The sketch is just important to help you understand that like as t goes this way, h got bigger to a certain point, and then h got smaller again until it hit the ground. And because this is about launching a rocket, I probably don't even have to pay attention to anything past the like ground points. Is this okay with everybody? Yeah. So if you feel stuck when you read a problem like this, I first want you to go back to the equation and say, do I even know what the equation is talking about? Okay, what is my x? What is my y? What do they stand for? The next thing I would want you guys to do if you're still feeling stuck is just want you to draw a basic sketch. Like just give yourself an x and y axis. Does the parabola go up or down? So you just understand as this is going this way, here's what's happening to the y thing, okay? Now I'm gonna go read their question and see which part of this I want. It says, will the rocket reach a height of 300 feet? So what are some ways that I can check if the rocket's going to reach a height of 300 feet? There's several ways I can do this. Morgan.
300 into a y place and then do the quadratic formula.
Okay, so one way to do this is to plug the 300 into the y place. And she said, then do the quadratic formula. Now, I don't necessarily disagree. If I do the quadratic formula, I would be finding exactly when it reaches 300 feet. But did they ask me when it reaches 300 feet? No. They just asked me, will it reach 300 feet? So the question isn't, what are the solutions? The question is, does this have any solutions? How can I check that without having to do the entire quadratic formula? What's that? I can't hear you. Okay, you're not wrong. I'll talk about that in a second. What was your idea, Emily? So in this setup, I can just find the discriminant. So I'm going to move 300 over. Because remember, I don't really care what the answers are. I care if there is an answer to that equaling 300, okay? So my discriminant would be to check 150 squared minus 4 times negative 16 times negative 300. I don't know. You guys have calculators. 64 times 3. Is that right? Someone check. I did things like, I know 15 times 15 is 225. So I wrote 225, and then there would be 2 zeros from the two things multiplying. And then like I do know 4 times 16 is 64, but in my head I was trying to think about like 64 times 3. And I got 192 and then the 2 zeros from there. So like, yes, but not like the long way, like a shorter way. I tried to find number stuff. But can someone confirm I'm not completely off base here? All right, are we going to get a positive value here? I don't even really have to finish. Is 22,500 minus 19,200 a positive number? Yes. 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 Okay. So underneath the radical, I'll have a positive number. This problem doesn't care if it's rational or irrational. Is it going to be a real number when I go to plug stuff into my quadratic formula? Yes. So will this rocket reach 300 feet? Yes. Okay. It has answers to that. So yes, it does. Okay. And then you could explain because the discriminant is positive. I want to point out what Brandon said because it's a totally different way and it works as well. He said, just go find the vertex. If you find the vertex, right, you could do negative b over 2a, and you could get the x coordinate of the vertex, and then you can plug that into the equation to get the y coordinate. You don't even have to use the 300. And when you get your x and your y here, as long as your y is at or above 300, did your rocket reach 300 feet? Yes. Okay, so parabolas are kind of cool because there's all these different tools, but they come together in different ways. You really just have to understand the meaning of what's happening, though, or it's hard for you to use the tools adequately. Okay, is this okay with everybody that there's lots of options here? You could have gone and done the quadratic formula and solved it, and if you got answers, then you know there are answers to reaching 300. You could use the discriminant and say, I know there are answers because it's a positive value. You could have found the vertex and said the vertex is at or above 300, so definitely the rocket reaches 300. Lots of ways to look at that, okay?